And you can record it.
That's true, and then you guys don't have to do that either.
So we still have 18 carbons, we haven't changed the number of carbons, right? We're
Right.
just numbering from the other end because you guys are oftentimes more interested in the other end of things than us chemists. So the rule about the placement of the double bond, about it's always the lowest number for the direction that you're dealing with, is still holding. So this becomes an omega 6, or omega dash 6, or n minus 6, or however you guys want to write it.
Okay, so let's go to this n minus thing that I totally screwed up twice, sorry. Okay, so what he's saying, which makes more sense than what I was saying 2 weeks in a row, is that omega goes 1, 2, 3, 4, 5, 6, right? Forget, the n minus thing that makes total sense in my brain doesn't make any sense at all. So, I mean, it works for me, but that's it. So 1, 2, 3, 4, 5, 6. N minus and omega are totally equal. We're good. So forget that it's a minus, just write n dash, and it's at the 6th bond, and both of them go in the methyl to carboxylic acid direction. Is that way better?
Yeah.
Okay, do you want me to say that one more time?
Yes, please.
Okay, so this is the red numbers are the omega notation. We start at the methyl end and we go to the carboxylic acid end. 1, 2, 3, 4, 5, 6. The location of the first double bond is at the 6. The n minus, which I will now call n dash, same notation, is exactly the same as omega. Start at the methyl end and go 1, 2, 3, 4, 5, 6. The bond is the same going in the methyl to carboxyl direction. Is that better? Okay.
Yeah.
So this, use chapter 18. Chapter 6 does it in the weird convoluted way that I do it. Use chapter 18 because the way Dr. Yap is explaining it and the way chapter 18 explains it are the same. And I think it's much easier than the other way.
So if say on the exam, will you add, like if you're asking for n minus, then we just write n minus, or we just write it in the n minus
Exactly.
way?
If
Or
I
you're
said,
saying omega,
yeah, if I
we
said
just-
where's the first double bond here using n minus, you're gonna say 6. If I say using omega, you're gonna say 6.
Yeah.
If I say using delta, you're gonna say, well, we're going in the other direction, and you're gonna say 6. Yeah.
So, are there any odd numbers of carbons? There aren't, huh?
We have
Because every time it's always the same number.
so there are a few that end up in vegetables, like odd numbered carbons, and then they turned out to be gluconeogenic because we can turn them into intermediate. But for the most part, we stick with even numbers, and we actually add 2 carbons at a time to make them longer.
Okay.
Question?
Can we maybe name the name? You know how the way you wrote it, like 2 carbons, bond.
Oh, go the other way.
Well, can we name? You know how like the way you would name it with the numbers?
Oh, yeah. Okay. So yeah. So what? So can you finish what you were doing in the corner?
Oh,
Thanks.
And that's only for the n minus. That's for the.
because this only supplies number of carbons and the fact that there are 2 double bonds, you might combine it with one of these 4 things to tell you where the double bonds are.
And that's for IUPAC.
Right.
Okay.
Well,
Well, that's
no, it's not just for IUPAC.
You can do anything. So like if we were
It's a
gonna.
mix and match kind of thing.
If we were gonna, so let's number it first with IUPAC since we started first. Okay, so the delta. Let's number with the delta convention. So it's 18, 2, and this is where they are.
12.
And so the delta tells us where exactly the
The double bonds are, right.
Exactly.
It's the same as if you had it standing alone.
So for the IUPAC, it'd be 18, 2, and minus 6.
Yeah.
IUPAC's gonna have this fancy,
So
hard to
yes.
pronounce name.
Oh,
So
that's
we're gonna call them the n minus omega and the delta
Okay.
because the IUPAC is it's the same direction as the delta, but then the n minus thing is how I convert IUPAC to n minus in my head. So like that's what I screwed up. That now I totally understand. So thank you, Dr. Yeah. Okay. So yeah. So I will call them either n minus omega or delta, and you just have to know which direction you're numbering. So could you name this one in omega and n minus?
So then it would be
18.
2 at omega 6. 12. Same answer.
and then N
Just
minus.
because of the position of these particular double bonds happens to be
Right.
the same.
For
They're
us,
exactly a third of the way through the chain.
if we know that it's 18.2, so like if we go back to linoleic acid, like we know it's 18.2 omega 9 because of that thing that I said about the methylene carbon, where it's double bond, one CH2 and another double bond, we know where the location of the next one is. But that's in humans only, and that's what he was saying. As a chemist, he doesn't deal with humans only in the specific way that we make these things. There are all kinds of things in the lab, or in the universe that we don't deal with, so that's why this is more comprehensive than that. That's why when we shorthand an omega-3 fatty acid, the human way is knowing there's a methylene double bond till you're done with double bonds. The chemist's way is you better tell everyone where they are because they could be anywhere. Does that make sense? Okay, and we're